Hello, so we are now at lecture 2. So this is about transverse reinforcement or column ties. So dito, meron tayong two major areas, yung L sub O tsaka yung middle span. So L sub O is known as your critical region. And then ito yung middle span, wherein this is inside the unsupported length of the column. Unsupported length means nag-start from the top of the floor line to the bottom of the beam. To get the critical region or L sub O, you have three equations. So maximum of B or H, and then LU all over 6 or 450 mm. So you get the maximum of these three values. That is your critical region L sub O. And then L sub U minus twice of L sub O, that is your middle span. Ngayon, yung S1 or that is your spacing 1, dyan ay dito sa critical region. Tapos yung S sub 2, spacing dito sa middle span. Now let's take this. Maximum spacing between ties or cross ties is 350 mm. Ang ibig sabihin yan, yung center to center ng ties or cross ties. Kapag sinabing ties, yan yung mga hoops. Okay, so let's take an example. Yan. Yang paikot na yan, yan yung tinatawag na ties. Kapag naglagay ka ng ganito, ang tawag dyan ay cross ties. Okay? Or pwede rin ganyan. Tawag dyan ay cross ties. Meron din namang ganito ang cross ties. So, diamond, tawag dyan ay cross ties pa rin. Meron din namang ganito. Okay, so, ayan. Closed pa rin siya, pero nasa loob siya ng hook ties. And then, meron din siyang closed ties dito. Okay? So, cross ties ang tawag dyan. And, yung nagpapalibot sa buong rebar, column rebar, ang tawag dyan ay hook ties. Next, ang ibig sabihin ng maximum spacing between ties or cross ties 350, ibig sabihin for example here, okay, kapag yung column mo ay yung center to center ng hook ties initially ay lumampas ng 350. Okay? Let's say 400 yung center to center ng hook ties. So that is greater than 350. Ibig sabihin nun, kailangan mo nang mag-provide dyan ng cross ties. Okay? So either ganyan or diamond or closed ties. Next is eto. Ang ibig sabihin yan, yung center to center ng hoops is greater than 350. Kaya siya naglagay ng isang cross ties. Ganon din dito. Next, dito naman, possibly na yung center to center nung hook ties is probably greater than 700. Kaya dalawang cross ties ang inilagay. Okay? So, let's take this for example. Meron tayong column dito na may dimension na 430 mm. Sukatin natin yung center to center nung hoop. Okay? So, the center to center of the hoop is 430 minus twice of clear cover minus half of tie diameter minus half of tie diameter here. Or in short, that is 430 minus twice of clear cover minus diameter of tie. So this is simply 430 minus 2 cc minus d sub t. Okay, so that is 340 mm. This is less than 350. So okay lang. You don't need to provide a cross tie. Next is, let's check this 450 mm na section. So, let's compute your HX1. HX1, again, yan yung center to center nung hook ties. So that is 450 minus twice of clear cover minus diameter of tie. That is 360 mm. So that's greater than 350. So that means na-violate na yan. Kaya maglalagay ka ng cross tie. So yung 450 ngayon, na dalawang bakal dyan, maglalagay ka na dito ng extra vertical bar. Okay, so kung 25 mm yung dalawa, pero ang kailangan mo, dalawang 25 mm lang, pwede kang maglagay ng 16 mm dyan. Okay, so sa drawing ko, naglagay na lang ako ng tatlong 25 mm. Now, let's check yung clear spacing, yung center to center spacing ng hook ties na pinaka malaki. Okay, so ayan. So this becomes now 450 minus twice of clear cover minus twice of diameter of tie minus rebar all over 2 plus 25 plus 10. Itong 25 niyan, yan yung rebar. Yung 10, yan yung diameter of ties. Next, paano nakuha yung equation na yan? Okay, so ganito yun. First is, kukunin natin yung distance between the center of this outer rebars. Okay? So, this distance is equal to 450. Remember that the dimension of this column is 450. Okay, so that is 450 minus twice of clear cover 40. Ayan. Okay. Tapos, ima-minus natin yung dalawang diameter of ties minus half of this rebar minus half of this rebar again. Or that is simply minus diameter of bar. And then, remember na meron tayong rebar dito. So, hahatiin natin yan dahil meron na tayong dalawang space. So, this is now divided by 2. Okay, so na-compute na natin ngayon etong distance. So, this equation is basically this distance. Okay? Next is, kukumputin na natin ngayon eto. Remember na, ang kinocompute natin, yung HX, which is basically this. So, madadagdagan ngayon ng Ang na-compute natin kanina, remember na, ito yun ha. Yan. Tapos, madadagdagan ngayon ulit ng half ng diameter of bar, half of the diameter of bar here. So, this becomes plus 25 plus half ng diameter of stirrups plus half ng diameter of stirrups. So, plus 10. So, ang HX1 natin ngayon, okay, is now equal to 197.5. Okay? So, yan yung explanation nitong equation na yan. So, that is 197.5. You now compare this with 350 mm, which is now less than, kaya okay na. Next is, ganun din dito sa kabila. Sa other dimension. Let's say, we have a section which is 800 mm. Okay, so obviously, let's try 4 rebars. So ilang spaces ito? 4 ay 3, no? So 1, 2, 3 spaces. And then eto ngayon ang, let's say, ganito ang ating cross ties, ganyan. So, ito ngayon ang kukumputin mo na HX. So, sabihin natin HX2 yan dahil yung HX1 yung along X direction. Then, yung HX2 along vertical direction. And then, kukunin natin yung critical na HX, which is nasa gitna. Okay. Bakit ganito ang aking cross ties? As I've said before, yung diamond na cross ties, pwede yan. Pero, mahirap to sa actual construction. Nagre-reklamo yung mga steelman ko kung diamond ang ginagamit. Kung ganito naman, close ties, nagre-reklamo pa rin ang mga steelman ko. Kaya ang ginamit ko, ganito na lang. Single, which is also the same in principle. Mas madali lang itong gawin, okay, sa field. Kaya, ganito na ang aking example, which by the way, I use in actual practice. Next is, same principle as here kanina. This time, instead of 2 spaces, we now have 3 spaces. Okay? So, divided by 3. Plus 25 plus 10. So, lumalabas na 260 ang HX2, which is less than 350 mm. So, therefore, this is okay. Next is, note na ito na yung critical HX. Obviously, this HX is greater than this HX. Okay? So, okay na yung ganyang layout. Next is, we will now compute the spacing of stirrups within critical, or spacing of ties within critical region. Remember that this is your critical region, yung malapit sa support. Okay, bakit sinabi na critical region yan? Dahil malakas ang shear forces dito sa critical region or pinakamalapit sa support. Now, what is shear forces? Ganito yun. Let's say, meron tayong beam. Okay, tapos fixed beam yan. And then, meron tayong uniform load. Okay? So, let's say that is W. So, meron tayong support dito na WL all over 2. Then, you also have support here, WL all over 2. Okay? So, reaction yan. Ngayon, yung shear forces mo would be, so this is your load. And then, yung V diagram mo, your V diagram will be something like this. Okay, tapos bababa dyan. Okay, so yan. Now this shear value is simply W times L all over 2. Since this is uniformly loaded, first degree line yan. Okay, so ibig sabihin, dito pinakamalapit sa support yung pinakamalakas ang shear. So ito yung tinatawag na L sub O, critical region. Ibig sabihin, kung ito yung beam mo, dyan pinakamasinsin yung mga stirrups mo. Now, the same principle applies if this is a column. Okay? So, pag column naman, meron kang compressive forces. Yan yung L sub O. Ganon din dito sa taas. Yan yung critical region na L sub O. Likewise, mula dito sa taas, dyan yung pinaka masinsin na bakal. Or this is known as your S sub 1. Spacing 1. Pagdating mo dito sa middle span, dyan na malalaki yung spacing ng stirrups. Okay, so that is what we're going to do now. And then H sub X, this time, yung H sub X, wala na siyang subscript na number. Okay, yung unang sinawag natin kanina, yung horizontal HX is HX1, tapos yung vertical na HX is HX2. This time, kukunin natin yung maximum HX. Okay, so this is maximum among HX1 and HX2. Wala na siyang subscript. So, lumalabas na ang pinakamalaking HX natin is 197. Dito naman 260. Okay, so ang gagamitin natin ay 260. Okay, so we now compute your S sub X. Your S sub X is 100 plus 350 minus HX all over 3. Now, this is an equation. Okay? So, equation yan. Okay. What is your computed? And then, what is your, let's say, ang ating section ay 450 by 800. So, ito, in-adapt natin to, 450 by 800. So, that is our section. Next is, balik tayo dito sa HX. So, maximum of HX1 and HX2. So, that is now 260. And then, applying this equation, the spacing X is equal to 130. Okay? So, 350 minus 260 all over 3 plus 100 will give you 130 mm. Next, we now compute your required S1. Required spacing 1 is spacing in critical region. Dito. To get the required spacing 1, you have 3 conditions. You take the minimum of these 3 conditions. So first is minimum of B or H divided by 4. And what is minimum of B and H? So 450. Ito yung B. Remember that this is your B and then H yung pinakamalaking dimension. So 450 divided by 4 will give you 112.5. And then 6 times diameter of bar is 150. dB is 25. Okay? And then your SX na 130 taken from this equation. So ang minimum among these 3 is 112.5. Pero yan bang ilalagay mo sa detailing mo? Hindi. Mag-ground down ka. Pwedeng 112 or gawin mo na lang 110. In my case, gagawin ko siyang 110.